Now we're going to talk about telemetry radios. This is a radio I've been using for a long time, since it came out and was available on Ardu plane, Ardu copter, Ardu rover and stuff. This is a 1 watt, 900 megahertz, 915 ultra long range transceiver. For transferring telemetry back and forth between the platform and the ground station and or radio in your hand. This has been used for a long time on Ardu pilot platforms for lots of reasons. It also works on INav. This going to be just a little more complex than the other UARTs. Let's look at the pinout on the 765 wing to begin with. So if we look at the 765 wing, we've used up UART 6 and we've kind of reserved 4, and we've used up UART 2 and the I2C port right here. Next up is UART 7. If we look over here, we're going to see that TX7 and RX7 on UART 7 also have a clear to send 7 and a request to send RTS and CTS 7 associated with them. UART 7 clear to send and request to send is for the Ardu Pilot Telemetry 1. Well, that's this telemetry radio I'm talking about. So with the Ardu Pilot software in mind, it looks like the Maytech team set up this UART 7 right here to match the telemetry radio that we've been using for years on Ardu pilot platforms. So let's not try to swim upstream. We'll just keep using everything as it comes to us. You notice now we've addressed all 4 of these special pins right here, and thusly we have described basically everything from this line to the right. All these pins we've touched on now, and we've touched on these 3 over here. We still have these 6 and these 9 to go. Anyway, let's go ahead and go through this telemetry radio. So the first thing I think we need to see is the pin out on the telemetry radio, and that's this. This is, if you look at the radio in my hand, the pins along the bottom of this radio. And we've been soldering to these pins and putting connectors on these pins for years, so the Ardu pilots in our group are extremely familiar with this pin out. So if we look back real quick on the pin out of the 765 wing, it's highlighted here. We're looking for ground, 5 volts, a receive, a transmit for a UART, and a request to send and a clear to send. So we're looking for a ground, a clear to send, 5 volts, a receive UART, a transmit UART, and a request to send. Why, looky there. There's all 6 of them right across the bottom on this piece of hardware. Just one little rub. They're not exactly in the order we need them in. to simplify this, and I will go through these pins one by one here. Ground goes to ground, voltage goes to voltage, receive on a UART goes to transmit on the other side, and transmit on a UART goes to receive on the other side. It's like these two wires right here are crossed when you make a wire between them. RX does not go to RX and TX to TX. You can't talk that way. TX has to go to RX, RX has to go to TX. The same thing is true for clear to send and request to send. This is just a little step up in data communications, where in addition to transmit and receive on a UART, we have two other control lines where you have to request to send data and get a clearance to send data. I'm not going to get any deeper into the UART protocol for this. It's just another UART with two more control lines added to receive and transmit, called request to send and clear to send. So with that in mind, if we look again at our hardware out here, we can look at the other end that I've connected, and we can see that the ground here goes to ground on the radio. 5 volts here went to that third wire for the radio. Receive on the UART goes to transmit on the UART out of the radio. Transmit on the UART goes to receive on the UART on the radio. Let me remember which one this one is. Okay, that would be request to send. The blue one goes to, no, green one. Yeah, request to send on this goes to clear to send on the radio, the second pin, and clear to send on the flight controller goes to request to send on the telemetry radio. And that's the way I wired it up into another 6-pin connector. Now I have stripped down the 765 board from the RC receiver, the GPS and compass and stuff that I had hooked to it. We're just going to hook in the telemetry radio, and again we just do that by hooking this 6-pin connector to this third set of pins across the top. Oops, I missed one. There we go. There we go. That's that, right? Well, there's one little problem here. As you see, if I take my USB port and hook it into my flight controller, my telemetry radio isn't on. It has no power. Wow. Bummer. Yeah, you see, we have lights on our flight controller. Our receiver would be fired up, our GPS would be fired up, even our airspeed sensor would be working. Oh, bummer. You remember I told you, we go back to on screen, that this 4V5 and this 4V5 volts are also supplied when connected to the USB, but this 5 volts is not. This voltage, all these voltages down through here, these voltages, all the voltages right through this whole bus here, voltages here, here, in my humble opinion, none of them are applied until you have soldered up at least your battery to the flight controller board on these two pads up here. I'm not sure if the BEC board has to be soldered via these three leads to the top of the flight controller to be able to get a VX voltage. I certainly believe that's true for this power bus down through here. I don't think you get any power on these without the VXs here, without the BEC board soldered up. So this is where I told you, if you look here, this is a case of some of this stuff doesn't power up until you actually connect the battery. Now I'm going to connect the battery to the input, and we're going to turn the battery on. Wow, check it out. I have a power light. It's actually signaling me that it's ready to transmit and receive information. That's all I have hooked to this 765 board, and a battery, a little LiPo battery. That's it. Now, if I use a little telemetry radio, MRO telemetry radio, good product, and hook that to my computer, and I go into INav, I see that I now have a COM port, COM9. That's that little telemetry radio connected to the computer. And if I make sure I'm at 57600 and click connect, oops, oh, mistake. Let's back up. Let's actually shut this off. I'm so embarrassed. Let's actually go back in with the USB cable. I guess we really should configure. Oh, it's nice to be old. I guess we really should configure, hook to the flight controller with a USB. And again, our telemetry radio doesn't fire up. But by going to COM5 at 115.200 and clicking connect, we can connect to that flight controller, and we can come into the ports page here, and we're talking about UART7, remember? I can't remember where I dug this information out, but it connects that radio connects to the 765 board. Again, MSP, but it will not connect correctly unless you drop the baud rate to 57600, and that's when we click save and reboot. It saves and reboots. Oh boy. You can see the information stayed. We can come back out here, take our USB port out of the top of the flight controller. We can again plug in our little USB radio to the computer. We see INav has found that COM9, which is that telemetry radio this time. We can turn on our flight controller, thus turning on our telemetry radio, and drop the baud rate to 57600, and now we can click connect, and lo and behold, look. We just connected to the 765 wing via the telemetry radio. It's as if we got this little 20-mile long USB cable connected to the flight controller. And if I pick up the flight controller and rock it around, you can see on the screen that the accelerometers feel my movement and are reflecting that. That's all there is to putting the telemetry radio on the 765 wing. And remember, it doesn't get power. See, it's just sharing data like a bandit now. Doesn't get power until the board is powered. USB won't do it. USB won't do it. If my GPS is plugged into UART7, it won't be powered up. It won't be finding satellites when I'm hooked up USB. It will start finding satellites, etc., when I turn on the flight power. And if that's the way I want it to work, I can put the GPS on UART7 just as easily as I put it on 2. It's easily possible. Find a ground, find a voltage, find a transmit, find a receive, you're done. So in this case, also at the top, you see I have unplugged my GPS and my compass connected to it, and I've got red symbols up there because it doesn't like my GPS quality right now. They're physically unplugged. You can see on the table. That's it. A flight controller and a 915 megahertz telemetry radio. More useful in Ardu pilot platforms than in INav. Although it's just beautiful right now to connect to this in without a USB cable connected to it and be sitting here configuring things and working with a mission. Who knows? I suppose I could be connected running this mission control software while it's flying. But in Ardu Pilot, you're going to find there's MavLink data being transferred over this connection that really sends thousands of sensor readings back to the ground station in Ardu Pilot platforms. With this telemetry radio, as an aside back to what I was talking about on the RC receiver Crossfire, you remember there's a way to set up a MavLink channel on that RC receiver. Ooh, that takes the place of this telemetry radio. This telemetry radio is quite heavy, by the way. It's really a bummer to have to put it on a platform. 2 reasons. It's 1 watt. It's really busting out with power. And it's 950 megahertz. It directly conflicts with the Crossfire RC transmitter. I've got a 433 megahertz version of this coming at a 1/2 watt. So I'm getting around that problem. But not having it on the platform has a lot of benefits. And the fact that you can set up a MavLink link and a Crossfire Nano diversity receiver and transfer the MavLink data back to the radio instead of using this setup is wonderful. Then the RadioMaster TX16S radio, in conjunction with the Crossfire module, it's more the Crossfire module that does it. There's a Wi-Fi in the Crossfire module that lets you connect that Crossfire module in the radio in your hand to the Wi-Fi in the notebook ground station and transfer that MavLink data to the ground station mission planner that we've been doing for years, thus alleviating the need for this radio. Now, that comes with a caveat, if you think about it. Okay, it's wonderful that this little bitty postage size RC receiver is now sending my MavLink data back to my ground station in addition to everything else. But if this fails, I not only lose my RC link, I lose my telemetry link to the platform. If I put this radio transceiver on the platform and connect MavLink to the ground station that way, if my radio in my hand goes up in smoke, I lose radio contact with the platform that way. I can jump over, grab the mouse on the ground station and click return to home. The MavLink through this radio to the platform to the flight controller will bring the platform back to the home location and circle it. That link would remain if this radio is installed in the platform. If it's done over the RC link of the Crossfire receiver, that's a really sweet setup, but it contains the failure point of if the telemetry fails for some reason, you don't lose your RC link. That's entirely possible. I don't know that, I guess it could be possible that you lose your RC link and the telemetry remains, and you could still use the ground station to do a return to launch. It depends on what the nature of the electronics failure is within the electronics. But having a separate telemetry communications from the RC control signal communications is, to me, a little safer. That's why I ordered a 433 megahertz version of this to put on my platforms, so I can do either. I'm going to try it with the Crossfire receiver. I'll go over how that's done in the future, and I'm also going to have the 433 megahertz telemetry radio as backup. I just want to be really for sure. So I'm not sure what else to say about this. That kind of completes the 915 megahertz or a 433 megahertz or whatever megahertz of telemetry radio working with the 765 wing.